Hello and welcome back. This is Greg French. Today we're going to talk about Cisco router basics, classless interdomain routing, and variable length subnet mask. That is abbreviated CIDR and VLSM, and we're going to modify a Class A address to show you how this best works for our networks. Here's a typical network that we've been using with 3 routers and a couple of PCs. If you look at the networks here, we've got 4 networks, 10.1.4.0. We have a /22. Now this 22 would represent the CIDR notation, and the 22 represents the number of network bits that are assigned to this particular network. So we've got 8 bits here, 8 bits here. You look down at this subnet mask. The first 2 octets are 8 each, but that third octet only has 6 bits. 2 of the bits have been set aside for the host side, which adds more hosts than we would normally get by having only 8 bits here. So the networks again, 10.1.8.0, 10.12, and 10.1.16. Now the reason they're jumping from 4 to 8 to 12 to 16 is again because we have taken away the 2 low order bits in this third octet. And those 2 low order bits are the numbers 2 and the number 1, which gives you 3. And if 3 minus the 255 gives you 252. But also, those bits now have been reserved for the host side, so we can't set them high. The first bit that we can set high is the third bit, which is the number 4. So each of the networks here cannot be in any combination with numbers 1 and 2, so we have to jump by an order of 4. So 4, 8, 12, and 16. If we look at the Class A that we're modifying, normally the Class A network has a range of 1 to 126, or about 126 networks. The host side, though, is huge. It's got 3 octets, or 24 bits. 2 to the 24th gives you over 16 million hosts that we would be able to assign IP addresses in a particular network. Way too many to be practical. So we need to do something. Here's a typical Class A address for 10, 10.0.0.0. Again, the default subnet mask for Class A is 255.0.0. One network, network 10. The CIDR notation, /8, and that 8 represents the network bits that have been set aside for our Class A network. So that's 8 bits. If we subnet this Class A, the first thing we might do is take the second octet and set those aside for network, and that would give you your range here. Having 255, 255 in the first 2 octet means we have 16 bits now in our network side and 16 bits in our host side. So what we've done, we have a CIDR notation here, a /16, showing again the 16 bits. And what we've done is we've added 8 more bits by taking this next octet here and assigning those with all 1s. If you take 2 to the 8th power, you get 256. Taking 2 away from that gives us about 254 networks that are available for assigning now. Started with 10, and we just added 254. Now we still have 16 bits on the host side, and 2 to the 16th gives us 65,536. Take away 2, you still end up with 65,534 hosts are available that we can assign IP addresses to. Again, too impractical. 65,000 plus hosts makes that network way too large to be functional or efficient. Next thing we can do as we continue going on this is taking 8 more bits and assigning those to a network. So now we've got 8 and 8 and 8, or 3 times 8 is 24 bits assigned to the network. This creates another subnet. We're taking again those 3 octets, and they're all set with 1s, and each one of those octet gives you a number 255. The CIDR notation /24 showing 24 bits or 3 octets, 3 full octets are now assigned to a network. This adds 16 bits to that first 8. Gives you 65,536 minus 2, or 65,534 new networks that would be available to assign But that only leaves 2 to the 8th power, or 256, that last octet, minus 254 hosts that would be available for signing. Again, 254 is not practical. It's too small for today's LAN networks. More like 1,000 or possibly 2,000 would be a better number. So what do? Well, we're gonna break up this third octet. And what we're going to do is we're going to take some of the bits in this third octet, assign them to the network side, and then we'll reserve some of the bits for the host side. This is where the variable length subnet masking comes in. We're assigning new subnet masks that we haven't seen before. Normally the subnet masks that we've seen, class A is just 255.0.0.0, class B 255.255.0.0, and then the class C 255.255.255.0. But this new subnet mask, we have 252 introduced. And this is a little different, but this is where our variable length subnet masking comes in. We've taken away 2 bits. If you look at this for the third octet, if we set these first 6 bits high and we set the last 2 bits 0, we get 252. What we've done is we've taken the 2-bit and the 1-bit, which is 3, and we've taken a 3 away from 255, and that leaves us 252. That's where the 252 comes. We've taken these 2 bits in our subnet mask, and we've put them into the host range. That'll add a lot of new hosts that we're going to be able to create. Now, we still have 22, or minus 2 from the 24, 22 bits left, so we slash our network with a 22 for the CIDR notation. We've added 14 bits now to our network side. Well, 2 to the 14th power is 16,384 minus 2, 16,382 networks that are now available. And now we've increased the host side to something that's a little more reasonable. We have 1,022 hosts. That's because we have 10 bits, the original 8 plus 2 more. That if you take 2 to the 10th, you get 1,024. Take 2 away from that, we end up with 1,022 hosts available. Now this is a much more practical network. We have a lot of networks that we can assign here, and for a good size organization, you might need several thousand networks. And we have a pretty good size host network LAN available too to assign. But for a lot of the new networks today, you might want to go up to about 2,000 hosts, and that's easily done. We just take 1 more bit. Now you can see that we only have 21 bits assigned to our network range. What we've done is we've taken 1 more bit in this third octet, and we've assigned it to the host range, and we've taken a bit away from the network side. So we went from 22 bits to 21. Now, we still have 8 bits assigned to this first octet, so now we have 13 bits we're working with. So 2 to the 13th, we come up with a little bit more than 8,000. So take away 2, you get 8,190 networks available. But we've doubled our host range. We've gone 2 to the 11th instead of 2 to the 10th, and we have 2,048 minus 2, or 2,044 hosts available. So this is probably a much better subnet for a Class A, and you might see this in a lot of medium to even large size organizations, and maybe a lot of school districts would come up with this. This again is our typical network that we have subnetted. Again, with the 4 networks, we've taken away 2 out of this last octet. We've added them to our host side, which has increased our hosts to 1,022, and we still have a large number of networks on this side. This pretty much concludes the classless interdomain routing, which is just our notation for CIDR, and you can see it here, /22. That's a CIDR notation. And again, we've introduced the variable length subnet mask, which gives you a subnet mask other than 255. Thanks for watching. Hope this helps clear up a little bit on that CIDR and variable length subnet mask. Thanks again. Bye.